All right, hello, my Windsor students. This is part 2 of pre-foldable number 1. And for this one, we're going to do our f of x is equal to x cubed. And once again, we're going to go ahead and plug in our -2, -1, 0, 1, and 2. We're going to go ahead and get these going. So we have f of x, or f of -2, is equal to -2 cubed. Well, -2 times 2, or sorry, -2 times -2 is +4. +4 times the last copy of -2 gives us a -8. And then we have f of x of -1 is equal to -1 cubed, which is -1 times -1, which makes +1 times -1 gives us a -1. F of x of 0, or sorry, f of 0 is equal to 0 cubed, which is equal to 0. We have f of 1 is equal to 1 cubed, which is equal to 1. And f of x, or f of 2, is equal to 2 cubed. I guess you should put these in parentheses, because we are substituting in from this equation, is equal to 8 as well, because this was 8 here, but this was negative because it's negative. This is positive, so this is also going to be +8. So for this one, we have -2 and 8. -1 and 1, 0, 0, 1 and 1, and 2 and 2, 4, 6, 8, and 2. It's right there. So this graph looks like this. Starts a little lower, comes up, connects the dots, and goes all the way up here, all the way from -infinity to +infinity. All right, the next one, oh, sorry, this is called the cubic. And this should be on this side as well. So we have, go from the top, we have this is linear, quadratic, cubic, and our last one's going to be our absolute value function. All right, so once again, we're going to go -2, -1, 0, 1, and 2. But this one we have absolute value. And just in case you don't know what absolute value is, absolute value is basically the distance from 0. Okay, so if you look at the chart here, like say we did a thing, this is 0, and this is here our -2, this is here. So it's looking for the distance from 0. So the distance from 0 is this distance here. And this is 1, 2 units away. So our distance from -2 to 0 would be 2 units, because distance could never be negative, right? You can't, even if you walk backwards, you're walking backwards to positive distance, or whatever, however much distance you're walking. You can never really go negative distance. You're just going a different distance in a different direction. So that's all this is really looking for. When we see absolute value, it just basically means the distance from 0. And for this one here, just like we explained, the distance from 0 is 2 units, 1, 2, okay? So f of -1 equal to absolute value of -1 is the same thing. Now we're at -1. So the distance from here to here is only 1 unit. F of 0, so is the absolute value of 0. Oops. Well, the 0 is at 0, so it's not moving anywhere. And we know that f of 1 is going to equal to the absolute value of 1. It's also going to just get equal to 1. And f of 2 is going to equal the absolute value of 2, which is just going to equal 2. Because either we do it here too, at 1 or at 2, the distance from here to here is still 1. The distance from here to here is still 2. This is why -2 and 2 have the same answer for absolute value, because the same distance here for 2 is the same distance here as well for 2. Okay, now that being said, we can go ahead and graph. So we have our -2 and 2, which is about right there. Our -1 and 1, our 0, 0, our 1 and 1, and our 2 and 2. So this one here would look like this. Oh, we should probably use a protractor, because these are straight-ish. Well, they're not lines, they're rays. Because an absolute value is actually made up of 2 rays that are connected at the same endpoint. Okay, so that's that right there.